During recent months, I saw a lot of conversation and questions sparked by the release of CRO, like those over there somewhere. Many of them are related to comparison with Helm. Some people think that CRO is more or less doing the same work as Helm. Others think that it is a different syntax that accomplishes the same result as Helm. Some are asking whether CRO is a replacement for Helm. There's hardly a day that I don't see a blog post or a Slack conversation or a question in Reddit around that subject. I want to answer those questions today. I will show that some of those are completely mistaken while others are right. CRO is very different from Helm and it is based on very different ideas, while at the same time it can replace Helm if you choose that path. I feel that those questions and doubts are a repetition of the same conversations we still have, in relation to differences between infrastructure as code tools like Terraform and Pulumi on one hand, and control plane tools like Cluster API and Crossplane. The major difference is that those same questions that were focused on infrastructure are now focused on applications. That being said, this is a much wider conversation. It is a conversation about the differences between client and server-side operations. It is about templates versus operators. It is also about Kubernetes pods versus deployments, no matter how strange that might sound. It is about our own and third-party custom resources. It is about some tools not understanding the change brought to us with the introduction of custom resource definitions and controllers some 7 years ago, and the evolution of tooling that help us create and manage those. Ultimately, it is about the evolution of Kubernetes itself and whether we should embrace it. Today's video might be a bit strange. It will sound at times that I lost my mind. You will likely think that I lost it and that I should have a conversation with a psychologist. Now, we'll see about that later. Now, the important note is that I will be using Helm and CRO today. However, everything I say about those can be applied to many other tools. Almost everything I say about Helm can be equally applied to Customize or Timoni or YTT or KCL or any other similar tool that does client-side templating or overlaying. Similarly, everything you will hear about CRO equally applies to Cluster API, Crossplane, Kubevela, or any other tools that help us manage resources through Kubernetes custom resource definitions and controllers. By the end of this video, you should have a clear, or at least a clearer picture of the differences between Helm and CRO and other similar tools. We'll see how they differ, which one you should use, and whether they are mutually exclusive. It all starts with the Kubernetes cluster, which in my case is running in UpCloud. I'm using UpCloud more and more since it's easy to use and it is cheap. It provides Kubernetes as a service, database as a service, and others. You can manage whatever you need through their web UI, CLI, Terraform, Ansible if you're desperate, and Crossplane, my favorite. If you haven't used it already, I invite you to check it out. You can use the sign up link somewhere in the description to get $50 of free credits, so it won't cost you anything to try it out. Nevertheless, today we are not talking about UpCloud. We are talking about different ways we should manage resources in Kubernetes clusters. What does matter for today's topic is that I would like to deploy an application into that cluster. How should I do that? Should I create the Helm chart? If I do, what should be inside that chart? Should it contain low-level resources like pods? Maybe? Should I resort to something else? Should I use templates with Helm? Are there better alternatives? A lot of questions. Actually, I don't have many questions. I'm just imagining that I forgot everything I know and that I'm acting as a newbie trying to make some decisions. Now, let's say that we would like to have a single replica of an application. We can do that with the following manifest. That's a definition of a pod which will contain a single container based on the silly demo image. Now, if you have any experience with Kubernetes, you probably think that I lost my mind. Almost no one, and I repeat, no one creates pods directly. We have deployments and stateful sets and other types of resources that do a much better job than that. Now, I can safely say that I am not insane. My mother had me checked when I was small. Bear with me, I'm trying to make a point which will hopefully become apparent soon. So, if you're familiar with Kubernetes, ignore everything you know for a few minutes. Imagine that neither you nor I know any better than to create pods. Now, if you would like to have that application up and running, all we would have to do is to apply that manifest. That was easy, right? Now, let's say that we would like to have a second replica of that application. So, the question is, how do we increase the number of replicas? How about having a definition of a second pod? That one is the copy of the other pod. The only difference is that this one is named SillyDemo02. Everything else is the same, since replicas of an app are most of the time the same. So let's apply it and take a look at the pods. There we go. Now we have 2 replicas. At this point, you probably do not believe that I'm not insane. Why would I deploy 2 pods separately? Still, bear with me. I know that what I'm doing is silly and that no one should be doing it. I want to make a point and you will have to bear with my insanity for a while longer. Now, let's say that we want to scale our application by adding a 3rd replica. That's simple, right? We just add another pod that is the same as the others but with a different name. There is no even need to look at the manifest. Let's just apply it and take a look at all of them. We scaled our application to 3 replicas. Now, let's say that the usage of our application dropped and we would like to scale it down so that the app does not waste resources. That's easy as well. We just delete one of those 3 pods, right? There we go. Now we are back to 2 replicas of the application. How about deploying a new release? We do not want to replace all those pods at once, since that might result in downtime. Instead, we might want to do some sort of rolling updates by changing the image 1 pod at a time. Here's a modified version of the manifest of the first pod. The only change is in the image value of the first and the only container in that pod. So let's apply it and take a look at the pods. We can see that SillyDemo02 restarted once. That was necessary since we cannot change the image of a running container, so the old pod was shut down and started again with a new image. Next, we should repeat the same process for the other pod, and once we're done, we'll have a new release rolled out to all the replicas of the app. Now, as a sign that I'm not insane, I will skip this charade and get straight to the point, right after we delete the silly mess I created so far. Okay, so we are done with charades, and I promise that I'm doing all that not because I'm insane, maybe a little, but because I want to make a point. Why was it silly of me to manage replicas of my application by applying pods directly? The answer is simple. We have higher level resource definitions and controllers that can manage pods for us. That would be, for example, Kubernetes deployment. Do we all agree on that one? Do we all agree that operations like management of lower level resources like pods should be delegated to a resource definition and a controller that is specialized at performing such operations? Do we agree on that? Now, I can safely say that a Kubernetes deployment or a stateful set or something similar is a much better choice than managing pods directly and performing such management from a laptop. Using deployments to manage replica sets which manage pods is, in vast majority of cases, a better choice than working with pods directly. Now, if you want, you can let me know in the comments if you disagree with that, and we will have a fight, which I'm certainly going to win. I dare you to tell me that deployments are worse way to manage stuff than pods directly. Now, a deployment consists of 2 parts. There is a resource definition and a controller. Resource definitions extend Kubernetes API so that we can send a request to, let's say, apply a deployment, and controllers, on the other hand, are processes that watch the events in the API, and when someone or something does anything with the resource kind they're watching, they do whatever needs to be done. If you created a deployment instead of all those pods, a single resource would manage them, and it would do a much better job at doing that. If we would say that we want a deployment with 3 replicas, it would ensure that 3 replicas are running forever and ever. If we would say that we want to upgrade those replicas, it would perform rolling updates, and so on and so forth. All in all, a deployment is, most of the time, a better choice than managing pods ourselves. If we all agree with that statement, and I hope that we do, we can also say that using higher level resource definitions and controllers is better than working on a lower level, as long as those higher level resources are doing what we need them to do. Managing resources on the server side like inside a cluster, is better than managing resources on the client side, like a laptop. All good so far? Are we all in agreement? It's important that we are, otherwise the rest of this video does not make sense. Now, many of you will say, great, I agree. Let's put a deployment into a Helm chart, since that gives us the benefit of templating and even more importantly, of value extrapolation. By the way, do not yell at me if you prefer a solution other than Helm. I do not like it myself. I think it is the worst solution of its kind. I'm using it today only because it is the most commonly used tool and format. If you prefer something else like Customize or YTT or KCL or CDKs or Timoni, be my guest. The point I'm about to make applies to all of those. All of them. Now, I already prepared a simple chart that will help us using the deployment instead of managing pods individually. Here is the values YAML file. Those values are equivalent to what we did so far. We can use them to change the image and the number of replicas. Here's the template of the deployment YAML itself. That's a simple one. There is a deployment with parts of it, like the name, the replicas, and the image being values. When we execute Helm install or Helm upgrade, Helm will, among other things, do variable extrapolation and effectively replace those with the actual values currently defined in values YAML. So far so good. If you have at least basic understanding of Helm, you did not learn anything new. And that's okay. I'm trying to make a point that will hopefully reveal something new, and I'm not there yet. I'm getting there, I promise. Let's deploy our vastly improved version of the application by executing Helm upgrade install and take a look at what we got. We applied a deployment, which in turn created a replica set which manages pods. Now, to be sure that we are on the same page, let's try the same operations we did with pods, but this time with the deployment defined as a template inside a Helm chart. If we would like to scale the number of replicas, all we would do is change the value of replicas, right? Here's an example. The only difference is that this time the value of replicas is set to 3, while the previous version had it set to 2. Let's apply the chart and start watching the changes to the pods right away. We can see that it created a new pod, then shut down one of the old pods, and then continued with the same process with the second pod. If we would like to scale down to 2 replicas, all we would have to do is to apply the same chart with the earlier version of the values. This time the deployment detected that we want to have 2 replicas and that there are 3 of them running, so it modified the replica set, which in turn removed one of the pods, and now we have only 2. That's brilliant. Yet something you already know. Remember, I'm not insane. My mother had me tested. I'm trying to make a point, and I'm halfway through, more or less. We could also change the image tag and apply the chart again. By doing that, we would update the deployment, which would create a new replica set with 0 replicas. From there on, it would start scaling up the new replica set and scaling down the old one until the new release is rolled out. That would be rolling updates process in action that is baked into deployment. Okay, now we can jump into questions. Do we agree that using a higher level resource definition and a controller, like a deployment, is better than using lower level resources like pods? I'm sure that I speak for everyone when I say yes, obviously. Do we agree that there was probably no need to have a Helm chart if all we have is a deployment? We could have just as well replaced some values in the deployment directly instead of fiddling with values YAML file. Take a look at this. That's a relatively simple definition that we could have used directly without a Helm chart. Just as we changed values YAML file in case of Helm, we could have changed replicas or image fields in that deployment directly. We did not get much, if any, value from using Helm with such a simple example. And that leads me to the next question. Do we agree that a deployment is not all we need? We should probably add the service and an ingress, and we might have a secret and a volume mount, and that we might have a service mesh and whatever else we need. Once we realize that we might need to combine a bunch of resources, Helm charts come in handy. They help us treat resources themselves as implementation detail and expose parts that matter, those that change, as values YAML file. All that leads me to say that all resources baked into Kubernetes are low level. Some, like pods, are lower than others, like deployment. Still, none of them alone give us what we need. There is no such thing as application or a database or any other type of resource that gives us something concrete and self-sufficient. That's why people love Helm. It allows us to have something meaningful. We can have a Helm chart that contains everything we might need to run a backend application, or a front-end application, or a database, or anything else. In those cases, values YAML becomes the interface, and files in the templates directory are, for many, an implementation detail. Helm and similar tools and formats are great, since they provide solutions that enable us to work with Kubernetes as if it has resources that are meaningful instead of being low level. And now comes the important part. I believe that last sentence is wrong, or to be more precise, ignores some other details. We'll get to that. Anyway, for now, I hope that we are all in agreement. For now, let's move into a more complex scenario. Let's explore a slightly more complex set of manifests by taking a look at ways to deploy a PostgreSQL database server into a Kubernetes cluster. One approach we can take is to simply install a Helm chart like the one provided by Bitnami. Why not? Now, it is important for the rest of the story to understand how Helm works. It is essentially a templating engine. Commands like Helm install or Helm upgrade do not send a chart to Kubernetes API. They don't. The API does not understand what a Helm chart is. Instead, Helm executes a process equivalent to Helm template to convert the template into raw YAML and then sends it all to the API. There's more going on there, but in a nutshell, that's what it does. Here's what, for example, Helm would generate and send to Kubernetes API if you would like to run a PostgreSQL through the Bitnami chart. Those are the resources that would be sent to Kubernetes API if we executed Helm install. That is, in a way, equivalent to managing applications by applying pods instead of working with deployments. Those are, in the case of a database, low-level resources. The main thing we are getting with Helm chart is that those resources are hidden from us, and that's okay. The problem, as I will argue later, is that they're hiding in a wrong place. Here's a better way to manage a PostgreSQL database server in Kubernetes. That's simple, isn't it? It is arguably just as simple and just as intuitive as if we focused only on the values file in case of the Bitnami chart we saw earlier. The major difference is that we are now looking at cloud-native PostgreSQL or CMPG, which is a custom resource definition and the controller. It is conceptually the same as the deployment we argued for earlier. That CRD extended Kubernetes API so that it now accepts resources based on a specific schema and that there is a controller that will manage all the low-level resources required to run the database. More importantly, that controller will take care of operations. It will do backups and restores. It will scale up and down. It will ensure the desired state and so on and so forth. CMPG and other similar solutions are arguably much better choices than running a database server only through Kubernetes resources baked in. I doubt that many would argue in favor of using something like that Bitnami Helm chart over a proper PostgreSQL operator. If you do argue, that would be whether to run databases in Kubernetes, and if you do, which operator to choose. Bitnami and similar Helm charts are not options in those arguments anymore, at least not among those running databases seriously. Both CMPG and deployment are resource definitions and controllers that are designed to manage Kubernetes low-level resources from inside, and I repeat, from inside a Kubernetes cluster. There are two major differences though. First, and the most obvious one, is that CMPG is even higher level than deployment. While deployment is managing only replica sets which manage pods, CMPG manages much more. There are also pods, but also services and roles and secrets and pod disruption budgets and backups and restores and many other things. The second difference is that deployment is a resource definition and a controller that are baked into Kubernetes, while CMPG is a custom resource definition and controller that need to be installed in a cluster. It would be silly for Kubernetes to come with everything baked in, and we are supposed to extend it to fit our needs. And now we are back to the similar situation as with the deployment. We have a single resource that defines everything we need to run a database, and the controllers inside the cluster are doing the heavy lifting of managing everything that needs to be managed. So here's the question. Is it the same using that Bitnami chart and CMPG? It's not. CMPG is better from the operational perspective, and it is easier to use and define from the user perspective. CMPG resources are in a way equivalent to Helm values file, except that CMPG has a discoverable schema while the values file is just a file. If you would like to discover how to operate that chart, we can execute Helm show values. That's not a real schema, but a list of values we can provide to the templating engine of that chart. Kubernetes API, on the other hand, has a real schema and validations of that schema. We can get it from any resource definition in the cluster, including, in this case, for CMPG clusters. If you would want to, we could retrieve descriptions, additional info, or anything else related to that definition, and it works no matter whether we use Helm, customized KCL, or anything else. That is a proper schema enforced by the API. Similarly, it would be very difficult to implement a solution for policies, since in case of Helm, we would be dealing with a bunch of low-level resources that are not unique to that chart. For example, it would be difficult to define a rule that is applied to pods only if they come from a specific chart, since pods are used all over. On the other hand, with the introduction of CMPG, we could easily create a policy that is applied only on the CMPG cluster resources. There are many other differences, but it all boils down to Helm being a templating engine that sends raw YAML to Kubernetes API while CMPG extends that API. Similarly, Helm is doing something only when we execute a command, while a controller, like the one installed through CMPG, is providing in-cluster operations running continuously. Now, let's apply that chart so that we see a few more differences. And to make it fair, we'll apply CMPG resource as well. Now, let's say that we would like to list all the databases running in the A-Team namespace. Now, we cannot do that with Helm since we never created a database. We just applied a bunch of resources that together compose everything a database might need. The best we can do is to list all Helm charts in the A-Team namespace. With Helm, we got a list of all charts that were applied to that namespace and would need to use some kind of a silly filter to retrieve only those coming from the PostgreSQL chart. With CMPG, it does not matter whether we use Helm or anything else. We extended the API and now we can get all clusters. Not only that we could easily retrieve all PostgreSQL clusters, but the output is specific to it. We can see how many instances are running, whether it is ready, what the status is, and which database is primary. We cannot do that with Helm since it treats all charts equally. Now, let's say that we would like to find out which resources were composed by that database server. In case of Helm, we cannot, at least not easily, ask it for all related resources and their statuses. What we can do is, for example, to ask it to get the manifest of silly demo DB. Now, that does not give us the status of those resources or any other runtime information, but only the resources that were created by that chart. From here on, we would need to look for a Helm-specific add-on or something similar to get the runtime information. With CMPG, it does not matter how we applied it. It is a Kubernetes resource, and any tool that works with Kubernetes can be used. So, for example, we can use kubectl tree plugin to display a tree-like relation between a specific resource and resources it composed. Now we can easily see that the cluster created a persistent volume claim and the pod and other resources. We can see their statuses, when they're available, the age, and so on and so forth. We could not use kubectl tree to retrieve all child resources of the Helm chart we installed simply because there is no parent resource, like in case of CMPG that created them all. We could retrieve all the resources from that chart by filtering through labels, or through some Helm plugin, or through some dark magic and sorcery. It's possible, but not as simple. Okay, so hopefully I managed to convince you that CMPG is a better choice than a Bitnami Helm chart. Assuming that we still agree that using a deployment is better than managing individual pods, we agreed that using higher level resource definitions and controllers is the way to go. Similarly, if I did convince you that CMPG or a similar operator is better than, let's say, PostgreSQL Helm chart released by Bitnami, I convinced you that using custom resource definitions or CRDs and controllers is the way to go. In both of those cases, we can wrap it all up into a Helm chart, but we don't have to, since all those are so short and simple that they can stay as pure YAML. I mean, that part is up to you. Okay, so now that we are in agreement that resource definitions and third-party custom resource definitions and controllers are the way to go, the logical question is whether when your stuff is concerned, we should keep defining Helm charts or create our own CRDs and controllers. Assuming that we agreed about everything so far, it would be hard not to choose your own CRDs and controllers over, let's say, Helm, as long as defining them is not hard or time demanding. I honestly don't see how you would disagree with that last statement if you agreed with previous ones. On the other hand, if you do disagree with most of what I claimed, you think not only that CMPG is not the way to go, but that CRDs and controllers like Argo CD, Caverno, Istio and others are not a good idea. Today we might be discussing whether Argo CD is better than Flux, but not whether they should be CRDs and controllers. This is the moment when CRO jumps in. It allows us to easily create CRDs and controllers that will do what we need them to do and in the way we want them to do it. More specifically, it allows us to compose resources based on custom resources we apply. Now, to be clear, today I'm not advocating in favor of CRO. I do not think it is a good solution, at least not today. Crossplane is years ahead of CRO, and I strongly suggest adopting it instead of CRO. The main reason why I'm using CRO today is in the Helm versus CRO debate going on during the last couple of months. That's the reason we're into it now. So, we established that we cannot apply a chart to the Kubernetes cluster, so Helm is an engine that converts a template into YAML and applies it to the cluster. Helm is not doing anything with the resources inside the cluster except when we execute a command. It is not operating those resources. We also established that using CRDs and controllers is better than using low-level resources baked into Kubernetes, and that it does not matter whether we define custom resources based on those CRDs as YAML or wrap them into a Helm chart that will convert the template into that same YAML. All in all, using custom resource definitions and custom resources is the way to go. And the only thing left to discuss is whether we should use them only for third-party apps or we should create our own as well. Now, creating CRDs was always easy. All we had to do is write a few lines of YAML. Writing controllers was challenging, but that changed with the emergence of tools like Kubevela, Crossplane, and others. One such tool is CRO. We can divide CRO manifests into two groups. There are resource groups or resource graph definitions that are typically written by people who want to define something as a service. That can be the same people who were writing Helm charts. Here's an example. Now, I will not go into details of that definition, mainly because this is not a CRO tutorial. If you're not familiar with CRO, please watch that video over there where I went through CRO and sprinkled it all with a bit of criticism. The only thing we should note is that the schema section will create a CRD and resources will tell CRO controller how to compose resources. So let's apply it. Next, let's switch to being a user who simply wants to deploy an application. That user would define something like the manifest that follows. Over there, we have a custom resource application. It could have been DB or cluster or anything else. It all depends on which CRDs we created with CRO through resource groups. That application defines the image, the tag, and a few other things. It is in a way similar to what we would define through Helm values file, except that this is now an endpoint, a CRD in Kubernetes API with all the benefits that gives us, and users do not need to deal with templates or charts or anything else. That is a Kubernetes manifest just as any other. Okay, so let's apply it and see what we got. Some of those resources are from the Helm chart and from CMPG, while others are from the CRO resource group. We can distinguish them through the names. Those from CRO are called Better Silly Demo, and we can see that the deployment and the service and the ingress are there. All in all, we defined a new CRD called application and a controller that is instructed to manage a few resources whenever someone creates a custom resource. There is nothing one needs to do to create those custom resources except to define a resource in the same way one would define a deployment, a pod, or anything else in Kubernetes. Okay, so we already established that using deployments is better than using pods directly, and that using third-party operators like CMPG is better than dealing with third-party Helm charts like the one from Bitnami, and that it would be beneficial to use CRDs and controllers for our stuff if it was easy. And we just saw that it was indeed easy. Defining, in this case, CRO resource group was just as easy or even easier than defining Helm chart. So it would be hard to complain that setup complexity is the deal breaker. Okay, let's reiterate. Creating CRD is just as easy as creating the default Helm values file. And for users, it is better to define high-level resources based on existing API and schema in Kubernetes than to create variations of Helm values file. Kubernetes custom resources are, in a way, equivalent to custom Helm values file, but just as easy and better. Next, creating Kubernetes controllers is just as easy as creating Helm templates. The major difference is that Helm templates are on a laptop or wherever we're executing Helm commands from, while controllers are inside a cluster. Those two are in a way similar in what they do. Both compose resources with controllers working continuously and performing whichever operations they should perform, while templates compose resources only when invoked. In the past, the barrier to entry into controllers was high. Now, they are just as easy as creating Helm charts. They provide many benefits, and we did not even go through the majority of them. At this point, I believe that almost everyone is familiar with Kubernetes, so any benefits one might attach to any Kubernetes controller that is baked into Kubernetes, like for example deployment, equally applies to custom controllers. A person that does not see the benefits of custom controllers will not see the benefits of, let's say, deployments, since both are based on the same principles and ideas. So, move your Helm charts to CRDs and controllers. There is no excuse not to do it since it is fairly easy. We saw a simple example with CRO, but there are many other solutions. I prefer Crossplane, and I can easily argue why it is the best currently available solution, but that is beside the point. The first step is not to pick one of those tools, but to acknowledge that CRDs and controllers are the way to go. Finally, I must say that Helm still plays an important role. Almost all third-party apps are available as Helm charts. If you need Argo CD, we'll set it up through Helm. If you need Istio, it's also Helm chart. If you need Prometheus, it is a Helm chart as well. However, more and more, those charts are used only to set up CRDs and controllers, not to operate those tools, nor to create instances of whatever those are offering. CMPG is a good example. I installed it through a Helm chart, which in turn applied a few CRDs and a controller. When it comes to creating actual database servers with CMPG, I did not use a Helm chart, but applied custom resources. Helm is here to stay for a while longer, but not in the capacity you might be using it. We are now in the era of custom resource definitions, controllers, and custom resources. They are replacing Helm and similar tools, but they are also very, very different in what they do and how they do it. Thank you for watching. See you in the next one. Cheers.